What is a function? Think of a function like a recipe or a button on a machine. You define the instructions once, and every time you press the button, call the function, it performs those instructions. Goal: to avoid repeating code. Benefits: makes code organized, readable, and easy to fix. In Python, we use functions to group code into reusable blocks. Let's look at how to build one. To define a function, we start with the def keyword. This tells Python, hey, I'm about to create a new command. Next, we give it a name, followed by parentheses and a colon. Everything tabbed over inside that block belongs to the function. In this case, our function will simply print the message, hello, from inside the function. Now, here is the important part: defining a function doesn't actually run it. If you execute your code now, nothing happens. To bring your code to life, you have to call the function. Simply type the function's name followed by parentheses. This acts like a trigger, telling Python to jump back up, execute the code inside, and then continue on. And that's it. You've just created your first reusable block of code. Right now, our functions are a bit static. To make them truly powerful, we need to give them information to work with. Think of it like a machine that needs raw materials to produce a result. We do this using parameters and arguments. While they sound similar, they have two distinct roles. A parameter is the variable name you put inside the parentheses during the definition. It acts as a placeholder. In our example, username is the parameter. It's essentially telling Python, expect a piece of data here later. The argument, on the other hand, is the actual value you send to the function when you call it. When we call greet_user and pass in the string Alice, Alice is the argument. Python takes that argument, plugs it into the placeholder, and executes the code. This allows us to call the same function with different data, like Alice or Bob, to get personalized results every time. Parameters are the slots, and arguments are the content you slide into them. Now your functions are dynamic. Up until now, our functions have been doing tasks and showing us the results using print. But in real-world programming, functions often act like consultants. You give them data, they process it, and then they hand back a finished report for you to use elsewhere. This is where the return statement comes in. Instead of just displaying a value on the screen, return sends that value back to the line of code that called the function. Look at this add_numbers function. It takes two parameters, a and b. Inside, we use the return keyword followed by the sum. When we call add_numbers, 5, 10, the function calculates 15 and literally becomes that value. Because the function returns a value, we can catch it and store it in a variable, like result. Now that number 15 isn't trapped inside the function, it's saved in our main program, ready to be used in calculations, saved to a database, or passed into another function entirely. One crucial thing to remember: the return statement is also an exit door. The moment Python hits a return, the function stops immediately. Any code written below that return inside the function will be ignored. Mastering return is the key to building complex, interconnected programs. It's how your code talks to itself. In Python, variables aren't always available everywhere. Where you create a variable determines its scope, or basically, who is allowed to see and use it. First, let's talk about global scope. If you define a variable outside of any function, it's considered global. Think of this like a public monument in a city square. Anyone, anywhere in your code, can see it and access it. But things change when you step inside a function. A variable created inside a function belongs to the local scope. It's hidden from the outside world. Think of this like a private conversation inside a house. People outside on the street, or other parts of your program, have no idea what's being said inside. Once the function finishes running, that local variable is actually deleted from memory. This is why you'll get an error if you try to print a local variable from outside its function. Python will tell you that the variable is not defined, because as far as the rest of the script is concerned, it doesn't exist. Understanding scope helps you keep your code clean and prevents different parts of your program from accidentally messing with each other's data.